In this video, I'll be solving the second problem of first session of AIME 2025. So we were given ABC are the points and ADB are in the order on this side length AB, and AD length is 4, DE is 16 and EB is 8. So 4, 16 and 8, and we are also having 4, 16 and 8, and we are also having that AF is 13, FG is 52 and GC is 26, and let M be the reflection of D through F and N be the reflection of C through G. So the quadrilateral DCGF has the trapezium has area 288, and we need to find the area of the heptagon. So if I consider this A, this A as origin 0, 0. So I'm considering a orthogonal model of coordinate axis where they are like inclined through an angle theta instead of our regular Cartesian system where we'll be having 90 degrees, like 90 degrees model where like all quadrants are at quadrant of 90 degrees. Now here like I'm considering a model where my coordinate axes are inclined. So I'm basically considering the skew coordinates. So let's say if AB and AC are my coordinate axis. So AB and AC, I'm considering it as my coordinate axis, which are at an inclined angle of theta. So if I take A as, if I consider it as an origin, and B if I consider, B will be 28, 0. Now AD is 4 and DE is 16 and EB is 8 is given in the question. So that means D would be 4, 0, E would be 20, 0, F would be 0, 13, G would be 0, 65. So the reflections, if we consider, so reflections with respect to this plane, so I'm not considering the actual reflections, I'm considering the skew coordinate system reflections. So for M, so M is the reflection of D through F, so M is nothing but 2F minus D, which is 2 times of this 0 minus D, which is minus 4, 2 times this 13, 26 minus 4, so that is minus 4, 26. And in a similar way, N would be 2E minus G, because N is the reflection of G through E. So this would be, so E is 20, 0, so 2 into 20, 40 minus G is having a x coordinate as 0, so 40, minus 65. So M and N are the respective reflections. Now, so if we are having, so AB and AC, so they are inclined at an angle theta. So let's consider the inclined coordinate system as having a angle theta. So that means area of this model, so area in this model, in this skew model, will be area of this coordinates in true, like area in Cartesian system, area in Cartesian into angle between this. So basically, suppose if we are having coordinates, so suppose like if this is having angle A, area A, now in the skew system, so for the same coordinates, the angle will be, the area would be A sine theta, given the angle between these coordinates is theta. So by using the skew coordinates, so I can find the area of DE, like trapezium. So first we can find the area of trapezium DEGF. So like in the true coordinate system, so that would be, we can simply do it by using Shoelace theorem. So 4, 0, E is 20, 0, G is 0, 65 and F is 0, 13 and again 4, 0. So if I use Shoelace theorem, 0 minus 0 plus 20 into 65 minus 0 plus 0 minus 0 plus 0 minus 13 into 4. So that means this would be 650 minus 26, which is 624. So this is the area in the Cartesian system, normal Cartesian system. So by using this we can find the area of this so we can find theta, because we already know that area of this quadrilateral is 288 in this new system. So basically by using this formula, so we know the area of, in the skew model is 288, so that is equals to 624. Area in the regular Cartesian system is 624 into sine theta. So that means sine theta would be 288 by 624. So 288 by 624, we can clearly see it is divisible by 4. So 4 sevens, 4 72s, and 4 ones 4, 4 5s 156. So again, like we can clearly see it is divisible by 4 again. So 4 18s and 4 3s 12 39. So it's divisible by 3 as well. So that means it is 6 by 13. So we got the angle of this coordinate system. So now like we can quickly find the area of this heptagon in a Cartesian system. So like for that, heptagon is AFNB CEM. So we already know the coordinates. So let me write once again. A is having 0 0. So F is having 0 13. N is having 40 comma minus 65, and B is having 28 comma 0, and C is having let me check for C ones. Yeah, C would be 13 plus 52 plus 26, which is 0 comma 91, and so C, E and M we need to find. So E is having 20 comma 0 and M is having minus 4 comma 26. So 20 comma 0 and M is minus 4 comma 26. So now like we can again use Shoelace theorem. So 0 0 0 13, 40 minus 65, 28 0, 0 91, 20 0, minus 4 26, and again 0 0. So this again like we are using by Shoelace theorem. Shoelace theorem of finding area of a polygon. So this is half into 0 minus 0 plus 0 minus 13 into 40, which is minus 520, plus 0 plus 28 into 65 plus 28 into 91 minus 0 plus 0 minus 91 into 20 plus 26 into 20 minus 0 plus 0 minus 0. So that means it is half. So half if I remove, minus 260 plus 65 into 14 plus 91 into 14 minus 91 into 10 plus 26 into 10. So that would be 14 5 70, 14 6 84. So 9 10 plus 14 1s 4, 14 1s 14, and 14 9s 126. So 1274 minus 9 10 plus 260 minus 260. So that means it will just be 1274. So 1274 is the area in the regular Cartesian system. So regular orthogonal model or regular skew, regular 90 degrees coordinate axis system. So the true area would be 1274 sine theta, and we already found what is sine theta. So sine theta we found it as 6 by 13. Sine theta is 6 by 13. So that means like 13 9s, 117 and 13 8s. So 98 into 6. So 6 8s 48 and 6 9s 54 plus 4 588. So the true area would be in this skew system would be 588. So we are simply using Shoelace theorem, and we are using a bit of unorthodox rectangular coordinates. Sorry, these are not rectangular coordinates. These are more of parallelogram coordinates, because in rectangular coordinates we have 90 degrees, whereas in case of the skew coordinates, these are like parallelogram based coordinates. So the true area would be 127. So 1274 is in the regular rectangular system. So in the new skew coordinate system, the area would be 588. So yeah, so that's it for this video. We'll meet in the next video.